Good morning, students and viewers. Welcome to my YouTube channel, Diligent Coaching Seminary. This is an academic channel in which I give you the tutorial videos based on the courses of schools and colleges level. Today also I have come with another videos. And before to start my today's tutorial lecture, I want to request all the students and viewers, please kindly subscribe my channels and press the bell icon such that whenever I upload new videos for you, you will get the notification. And I want to request all of you to watch the videos completely and get the benefit for your study. Today I have come here to give you the lecture for the class 10 science subject. In my previous video I have started to give the tutorial on the chapter force, and in my previous video I have explained about the concept of the gravitational force. Today I am going to continue the same chapters, and today I am going to discuss about the Newton's universal law of gravitation and the formula of the gravitational force and more concept about the gravitational force. So we'll start our lecture now. Now we are going to study Newton's universal law of gravitation. The famous scientist Sir Isaac Newton has given several theories in different topics of the physics. In class 9 you have already studied Newton's laws of motion, and there you have studied Newton's first law of motion, second law of motion, third law of motion, like that. And similarly Sir Isaac Newton has given the law based on the gravitational force as well. So now we are going to study the law which is given by the Newton, which is based on the gravitation. So now we are going to study Newton's law of gravitation. First of all, I want to say the statement of the Newton's law of gravitation. And the statement of the Newton's law of gravitation is like this. It states that everybody in the universe attract each other by the gravitational force which is directly proportional to the product of the masses of those two objects and inversely proportional to the square of the distance between their center. I will repeat it again. It states that everybody in the universe attract each other by the gravitational force which is directly proportional to the product of the masses of those two objects and inversely proportional to the square of the distance between their center. The statement is slightly longer. I am going to explain the statement. There are two parts in this statement, and the first part is the gravitational force of attraction between any two objects is directly proportional to the product of the masses of those two objects. That is the first part. And second part is the gravitational force of attraction is inversely proportional to the square of the distance between their center. So the meaning of this directly proportional and inversely proportional should be clear to you. First of all, the gravitational force of attraction is directly proportional to the product of masses of those two objects. It means when mass of those two objects is more, then gravitational force is more, and when mass of those two objects is less, then gravitational force is less. So this is the meaning of directly proportional to the mass. So the statement has said the gravitational force is directly proportional to the product of the masses of those two objects. So whenever mass of the object is more, gravitational force is more, and whenever mass of the object is less, then gravitational force is less between them. So this is the meaning of first part. And another part in this law is the gravitational force is inversely proportional to the square of the distance between their center. It means whenever distance between those objects is more, then gravitational force is less. Here is inverse relation, opposite relation. And whenever distance between those two objects is less, then gravitational force is more. So this is the meaning of directly proportional to the product of the masses of those two objects and inversely proportional to the square of the distance between their center. That means gravitational force of attraction is more in the case of bigger objects and it is less in the case of smaller objects. It will be clear from the first part that the gravitational force of attraction is directly proportional to the product of the masses of those two objects. That means bigger objects has more mass, and when mass is more in bigger objects, then the gravitational force of attraction is also more in the case of bigger objects. But in the case of smaller objects, it is clear that the smaller objects has less mass. That is the reason the gravitational force between the smaller objects is also less. So it is the meaning of the gravitational force is directly proportional to the product of the masses of those two objects. And now the meaning of inversely proportional to square of the distance between their center is when the objects are near, then the gravitational force of attraction is more, because when the objects are near, then the distance between those two objects is less. But when the objects are located far, then distance between them will be definitely more, and the gravitational force of attraction is also less in that case. So I think you understood the meaning of the statement. So the statement of the Newton's law of gravitation is, it states that everybody in the universe attract each other by the gravitational force, which is directly proportional to the product of the mass of those two objects and inversely proportional to the square of the distance between their center. And Newton's law of gravitation is also called Newton's universal law of gravitation. And what is the reason that the Newton's law of gravitation is called Newton's universal law of gravitation? I'll be explaining you just after a few minutes. Now from this Newton's universal law of gravitation, we can derive the formula for the gravitational force. So let's derive the formula for the gravitational force by using Newton's universal law of gravitation. For this, first of all, let's take two objects here as shown in the figure. You can see in the screen. Here we have two objects, and these two objects have mass m1 in the first object and m2 in the second object. So m1 and m2 are the mass of these two objects, and the distance between the center of these two objects is d as shown in this figure. And suppose the gravitational force of attraction between these two objects is F. So I have mentioned here, let us consider two objects having masses m1 and m2 and separated by distance d from their center as shown in the figure above. And suppose F be the gravitational force of attraction between them. Now, according to the Newton's universal law of gravitation, Newton's universal law of gravitation has said the gravitational force of attraction is directly proportional to the product of the mass of those two objects. So here we have written F, and this is the sign of directly proportional, and F proportional to m1 into m2, because the statement has said that gravitational force is directly proportional to the product of the mass. That means gravitational force is directly proportional to the multiplication of the mass. So F directly proportional to m1 into m2. The statement has said. Then the Newton's law of gravitation has also said the gravitational force of attraction is inversely proportional to the square of the distance between their center. So first of all, you have to know the inversely proportional means whenever we write mathematically, then we have to write 1 upon. Like if it is saying inversely proportional to the distance, then we have to write 1 upon distance. But it is saying it is inversely proportional to the square of the distance, so we are writing F proportional 1 by d square. It means it is inversely proportional to the square of the distance between their center. So I think you have become clear. Whenever statements say inversely proportional, then you have to write 1 upon something. Now combining these two relation I and II, we get F proportional m1 into m2 by d square. And you have to know this proportional sign can be replaced by equal sign, but for this we have to multiply by a constant, and here we have multiplied by the constant g. So what we have done here, proportional sign is replaced by equal sign, and here right side we have multiplied by a constant. This is the rule of physics. F equals to g m1 into m2 by d square, and here g is the proportionality constant, and it is also called the universal gravitational constant. So here g is universal gravitational constant, and from here we have derived one formula, F equals to g m1 into m2 by d square. So it is the required formula of the gravitational force, F equals to g m1 into m2 by d square. So this is the formula of the gravitational force which we have derived here. Now from this formula we have to know on which factors the gravitational force depends, and on which factors anything depend, it will be known from the formula. Okay? Whatever quantities are there in formula, it depends upon that. And you know, in the formula of the gravitational force, here is m1, m2 and d square. So gravitational force also depends upon these factors. That means the gravitational force depends upon the product of the mass of the objects, and it depends upon the square of the distance between their center. So here I have mentioned, here you can see in the screen, the gravitational force of attraction depends upon two factors. That is, one is product of the mass of objects, then square of the distance between their center. Now let's see the formula of the gravitational force detailedly. Here now I am going to clarify you in which condition the universal gravitational constant g is equals to F. Just now we have derived the formula of the gravitational force between two objects having mass m1 and m2, and which are separated by distance d, and the formula is F equals to g m1 into m2 by d square. Now we are going to see in which condition F and g are equal. That means gravitational force and the universal gravitational constant are equal. Let's see. And by equating this formula, we will obtain here g equals to, you know, F into d square upon m1 into m2 by the steps of equation. Then suppose mass of two objects m1 and m2 are equal and both are equals to 1 kg. That means suppose both the object has mass 1 kg. So m1 equals to m2 equals to 1 kg, and the distance between those two objects is 1 meter suppose. Then obviously g equals to F, is it or not? So g and F can be equal only when distance is 1, m1 is 1, m2 is also 1. That means distance should be 1 meter, m1 mass should be 1 kg, m2 mass also should be 1 kg. Then mathematically g equals to F. So this is the condition at which g is equals to F. That means the gravitational constant g is equals to the gravitational force F. So hence the universal gravitational constant is equals to the gravitational force between two objects when they have unit mass and separated by unit distance from their center. Having unit mass means having 1 kg mass, and separated by unit distance means 1 meter distance. So I think you become clear. The gravitational constant is equals to the gravitational force when the two objects has mass 1 kg each and they are separated by distance 1 meter from their center. Then mathematically it is clear that G equals to F. And from here we can define the gravitational constant G, because it is clear that the gravitational constant is equals to gravitational force when two objects has mass 1 kg each and they are separated by distance 1 meter. So this is the definition of the gravitational constant as well. The gravitational force of attraction between two unit masses separated by unit distance from their center is known as the universal gravitational constant. That means when the objects has 1 kg mass each and they are separated by 1 meter distance from their center, then how much will be the gravitational force of attraction between them in that condition? That will be equal to the universal gravitational constant. So the universal gravitational constant G is defined as the gravitational force of attraction between two unit masses separated by unit distance from their center. That is the universal gravitational constant G. And the value of the universal gravitational constant G is, you can see in the screen, it is 6.67 into 10 to the power minus 11 Newton meter square per kg square. And Newton meter square per kg square is the SI unit of the gravitational constant. So the value of universal gravitational constant Z is 6.67 into 10 to the power minus 11 Newton meter square per kg square. I think you become clear on this. Now you have to know in which direction the gravitational force of attraction acts. And the gravitational force of attraction acts in the straight line joining the center of the mass of those two objects. Now let's substitute all the SI unit in the formula of G, and in the place of force F we have written here Newton, in the place of distance D we have written here meter, so it is Newton meter square, and in the place of M1 and M2 we have written here kilogram, because all these are SI unit of this. SI unit of force is Newton, SI unit of M1 mass is kilogram, SI unit of M2 mass is also kilogram. So it will be Newton meter square upon kilogram into kilogram, and from here we have obtained Newton meter square upon kilogram square, and upon kilogram square can be written as per kilogram square. So it is obtained G equals to Newton meter square per kg square. So from here it is clear that therefore the SI unit of the gravitational constant G is Newton meter square per kg square. So I think you become clear why the SI unit of the gravitational constant is Newton meter square per kg square. Now we are going to see what is the gravitational force of attraction between any two objects having mass capital M and capital N and separated by distance r from their center. First of all, we know that the gravitational force of attraction between any two objects having mass M1 and M2 and separated by distance d is F equals to G M1 into M2 by d square. Now here first mass M1 equals to capital M and second mass M2 equals to capital N, and distance d between them equals to r. The question has said that, and substituting all these values here we obtain F equals to G capital M into small m upon r square. So this is the required expression for the gravitational force of attraction between two objects having mass capital M and capital N and separated by distance r from their center. Now let's discuss what is the relation of the gravitational force of attraction between two objects with their mass and the distance between them. And the relation is clear from the statement of Newton's law of gravitation, that the gravitational force of attraction between any two objects is directly proportional to the product of the mass of those two objects, that is F directly proportional to M1 into M2. This is from the statement of Newton's law of gravitation. and the gravitational force of attraction between two objects is inversely proportional to the square of the distance between their center. So F proportional 1 by d square. So here the gravitational force is inversely proportional to the square of the distance between their center. So this is the relation of the gravitational force of attraction between two objects with their mass and the distance between them. Now here is the one diagrammatic question. The planet revolve around the sun in the elliptical orbit, and suppose here is one planet which is revolving around the sun, and when the planet changes its position from A to B, then what will happen to the gravitational force? Let's discuss detailedly. The planet revolve around the sun not in the circular orbit. All the planets revolve around the sun in the elliptical orbit. Elliptical orbit means slightly oval orbit. All the planets have oval orbit around the sun. They do not revolve in the circular orbit. And when the planet revolve in the elliptical orbit, when the planet is located in this part B, then distance between planet and the sun is comparatively more. But when the planet is located in this part A, then the distance between the sun and the planet is comparatively less. And whenever distance is more, then the gravitational force of attraction is comparatively less, because the gravitational force of attraction is inversely proportional to the square of the distance between their center. Is it or not? So in this part B, the gravitational force of attraction is comparatively less, and the part A, the gravitational force of attraction is comparatively more, because here distance between the planet and the sun is comparatively less. And when the distance between two objects is less, then gravitational force is more. But when distance between two objects is more, then the gravitational force is less, because of this relation F proportional 1 by d square. So here I have mentioned the answer. The planet revolve around the sun in the elliptical orbit, due to which the distance between the sun and the planet is comparatively more at position B than at position A, and due to which the gravitational force is less in position B, and the reason is since F proportional to 1 by d square. I think you are seeing the answer in the screen as well. Now here let's discuss about the artificial satellite. Artificial satellites have been projected by the scientists in the space, and no fuel should be given to the artificial satellite to revolve around the earth. And because the gravitational force of attraction between the artificial satellite and earth plays the role of necessary centripetal force to revolve around the earth, and there is no air resistance as well in the space, due to which there is loss of initial energy. So fuel should not be given for the artificial satellite just for the revolving around the earth. Only because of gravitational force of attraction between the artificial satellite and earth, the satellite can revolve around the earth continuously. There should not be any energy given for the satellite to revolve around the earth. And the satellite never fall on the earth as well, because the gravitational force of attraction between the planet and satellite provides the necessary centripetal force for the satellite to revolve around the earth, and there is centrifugal force as well to balance the centripetal force. You have studied about the centripetal force and centrifugal force in your previous grades. Like centripetal force is when any objects revolve in circular motion, then a force acts towards the center, and that is called centripetal force. And when any objects revolve around the center, then a force acts outward the center, then that kind of force is called centrifugal force. So centripetal force acts towards the center and centrifugal force acts outward the center, and because of the centripetal force and centrifugal force, the object can move in circular motion, and so the satellites also do not fall on the earth because of the presence of centripetal force and centrifugal force, which is played by the gravitational force of attraction between the satellite and the earth. And all the planets are revolving around the sun in the elliptical orbit. This is also due to the gravitational force of attraction between the planets and the sun. And the effects of the gravitational force is comparatively more in liquid than in solid, because in the case of liquid the molecules are loosely packed, but in the case of solid the molecules are rigidly packed, tightly packed. So the gravitational force of attraction is comparatively more in liquid. Now for today I want to end my tutorial, and I hope you have understood the concept whatever I have given in my lecture. And I want to again request all the students, please kindly subscribe my channel and press the bell icon such that whenever I bring other more videos in this chapter, then you will get the notification and you will get benefited in your study. And I also want to request you to like and share my videos, and if you want the tutorial for the particular topic of the particular subject of the particular class, you can mention that in the comment box such that I can bring the required tutorial video for you here in the YouTube's. So I want to request you stay blessed. Thank you very much and goodbye.